Okay, we are working on 3.3 differentiation part 2 with the product and the quotient rule. So after we had a little activity in class, let's talk about the product rule as it stands dy dx. Suppose that so far we have a very limited list of functions that can be differentiated using rules. Okay, you have your power rule pretty much. Suppose you have a function that is the product of two functions, namely y is equal to g or f of x times g of x here. So in the product rule, we have dy dx is equal to f of x times g prime of x plus g of x times f prime of x. So the quick way to remember that is that if you look at your function where f of x is the first function and g of x here is the second function, then you could say that first der second plus second der first would give you a way to mnemonically remember the derivative. Okay. Then you have the quotient rule. The quotient rule is, suppose you have a function that is the quotient of two functions, namely y is equal to f of x over g of x, where f of x is the high and g of x is the low. Then you have the dy dx here is equal to g of x, f prime of x minus f of x times g prime of x all over g of x squared. So in this one, you could have the mnemonic where we say low d high, low d high less high d low, d meaning the derivative, over low squared, and away we go. So in that way, that gives us a mnemonic to be able to work with the quotient rule. Now, you don't want g of x to equal 0 because it's in the denominator, and then of course the function would be undefined in the original function, y is equal to f of x over g of x, and the derivative would also be undefined. So here we go. So the first thing that we pointed out here, and we going over this problem, we had the derivative that we wanted to take, and we end up finding the derivative after having simplified our function. So where here we have the function itself, we take and rewrite using exponents because we have different indexes in the roots, 3, 4, and 2. And so then we obtain a common denominator, or the index of 12 for the 12th root, and then we simplify the numerator, adding the exponents, and then we subtract the exponents to end up with our final form here of x to the 7/12. So then we're able to take the derivative here. Taking the derivative, then we get 7/12 x to the negative 5/12 to get to our final answer, which is 7/12 x to the 5/12. And I don't bother rewriting that in a root. You can if you like. Okay. So that before we start to do any kind of product rule or quotient rule, we want to make sure that we can simplify the expression first, and then makes our overall job of finding the derivative so much easier. So then the next one I have, find the derivative first by multiplying out and then using the power rule. And you can see as I multiply the x squared times x squared plus 1, I get x to the 4th plus x squared. Take the derivative, and you end up with this derivative, okay? Which is great. We have our answer, and that's a pretty quick way to do it. Showing that it's equivalent, we go ahead and we do the product rule with the same problem, where we have y prime then is equal to first der second plus second der first. And then we get our answer 2x cubed down here plus 2x cubed plus 2x, which is equal to the same thing right here. Okay, so then we have an example that shows that we can use the product rule and it produces the same result as our original problem in A. But we can't always multiply and simplify our two products, and that's what we're getting at with the eventual use of the product rule. So let's try this next one. So in the next one, we find the equation of the tangent line at 3f of 3 and 4f of x is equal to 3x squared minus 13x minus 10 over 9 times the quantity x plus, or 9 times 9x plus 6. So the first thing I'm going to do is I'm going to look, can I simplify this? So I look at the denominator, and that's pretty easy to factor. So in the denominator that is 9x plus 6, I can factor out a common factor of 3, giving me 3 times 3x plus 2. Then I look at the numerator, and I think it would be fancy if we could factor the numerator, since it's a quadratic. And I look at the first, and I look at the last, and I think, well, a 3x times x, and then a 10 would be a 2 times, it would be amazing if that was 3x plus 2, right? So I try to force the issue to see if that is a factor of the quadratic. And in this case, it turns out that it is. When you multiply things out, you would get the original polynomial in the numerator. Okay, so we're going to cancel the common factor. We cancel the common factor of 3x plus 2. So we end up with f of x is equal to 1/3 times x minus 5. Okay, so actually this is a line. Now, you can get the derivative in the equation for the tangent, but the tangent in this case actually passes through all points in the line. So after I simplify, I'm kind of shaking my head going, what? So we could say f prime of x is then equal to, if that's our f of x, is 1/3, right? So now watch what happens if we have our 0.3 f of 3. Now f of 3, in this case, I'm going to do this up here, save more room, is negative 2/3, right? Keep the 3 in the denominator, plug in 3, and 3 minus 5 is negative 2. So he's negative. So we would have y minus a negative 2, which would be y plus 2/3, equals 1/3 times the quantity x minus 3. And if you distribute, notice what you get. Y is equal to 1/3. Okay, and we're going to say 1/3 x minus 1, and then we have minus 2/3. Okay, so that turns out to be y is equal to 1/3 x, and that would be minus 5/3, which is the equation you get here. So this turns out, so the equation for the tangent line is the line itself, which is going to be discussed tomorrow. I have a little question for you. Is that a tangent line? And maybe you can come back with an answer for that. The next problem we're going to use the quotient rule on. And so we start off and we say, all right, f of x is equal to a quotient, which does not appear to simplify. X squared plus 9 over 7x minus 3. So we have low, d high, less high, d low. So the derivatives, low, d high, less high, d low. The derivatives are in yellow. Over low squared, and away we go. So there we go. We have our numerator, which if I have squared, it looks like I'm going to have an x squared term here, and then I have one over here, then I'm going to try to simplify them. But I'm not going to multiply the denominator to get 49x squared minus 42x plus 9. I'm just not going to do it. There's no point in it. So I simplify it. There are no, if you notice I have this marked off here, there are no common factors between the numerator and the denominator here. I try to factor it and say, hey, I wonder if I have a factor of 7x minus 3 in 7x squared minus 6x minus 63. So if I choose 7x minus 3 as a factor, then the other factor is going to have to be x plus 21. It'd have to be a positive 21 to produce a negative 63. It's not that fact, because if you look, we get way too high here. 7 times 21 is 140. 140 plus 7, 147. So that's not going to work out. So in this case, it doesn't factor. There's your answer. So again, here we have a quotient rule. We have f prime of x, and here is our high, and then we have our low. So we're going to say low d high. We always start it out low. Low is 3x squared minus 6x plus 1. D high is just 1. Low d high less high is x. D low is 6x minus 6. And that's all over low squared. So this is another example where I'm going to put in 3x squared minus 6x plus 1, and then I'm just going to square it. So now there is a tendency for students to go like this, but you can't do that. You can't do that because you can't cancel over addition. Subtraction is addition of the opposite. So I'm going to simplify the top of it. So what do we have? 3x squared minus 6x plus 1 minus 6x squared plus 6x. And I'm going to combine like terms there and there. And then it looks like I get a negative 3x squared plus 1 for the numerator. So I get negative 3x squared plus 1, and then that would be over the quantity 3x squared minus 6x plus 1 squared. And there would be your derivative. And that's all we're doing there. Okay? Finding the derivative. Okay. So there's the answer for that one using the quotient rule. And I have another one, but I'm going to say, again, you want to simplify before you go forward. Just check it out at the very least. So when I look at this one, I've got this x minus 5 in the denominator. And so I think to myself, is this an x minus 5 times x minus 2 or plus 2? And so you want to check out to see if the expression simplifies first. X minus 5 times x minus 2 is equal to the original polynomial, x squared minus 3x minus 10. And so we cancel, simplify. So when we get f of x, remember that before we take the derivative, f of x is equal to then just x squared plus 2x by multiplying the two factors that are remaining, x and, x and x plus 2. So we get f prime of x. Of course, x cannot be 5, but f prime of x is 2x plus 2. Okay, and there's the answer for that one. Okay, and now we're going to skip this problem. If you want to try those on your own, you can and check with me. We have a couple problems that are somewhat familiar, and the rest of these, I'm going to scooch all the way down here to these. And I want to do these a couple different ways. I'm going to do f prime of x is equal to low. Here's your low. Here's your high. So using the quotient rule with this problem, finding the derivative of f of x, we have x squared plus 4. The derivative of the high is just 1. The derivative of x plus 1. Low d high less high, x plus 1. Always careful to use parentheses too. Times the derivative, low d high less high d low, 2x here. And that would all be over x plus 4, the quantity, x squared plus 4, the quantity squared. Simplifying the numerator. So in the numerator, we're going to have x squared plus 4 minus, that's going to be a 2x squared plus 2x. And so then we're going to add the opposite here. So then in the numerator, we're going to get f prime of x is equal to, so that's going to be negative x squared. And then it's going to be minus 2x plus 4. Okay, so negative x squared minus 2x plus 4. So this is the first derivative over x squared plus 4 squared, and we can rewrite that as f prime of x is equal to negative x squared, so the negative out front, plus 2x, and then minus 4, and then that would be over x squared plus 4, the quantity squared. Tons of things that look like you can factor out and cancel, but you can't. X squared plus 2x minus 4, does it factor? No, not really, right? 4 and 1, if it was a 3x, it'd be nice, but that's it. So the last one, the reason why I wanted to show you, we're going to use product rule with this, and I'll show you how we're going to do this. So g of x in this case, g of t is equal to 2t plus 5. And that would be over t to the 1/2 power, right? Let me move this up a little bit. And I'm going to convert this to 2t plus 5 times t to the negative 1/2 power. Okay, so I now have a product. Here's my first factor. Here's my second factor. So I'm going to say g prime. So I could have used quotient rule with this, but I'm just going to do another product rule problem with you. G prime of t, a product rule by converting the expression. And many times when the denominator is pretty simple, it's easy to do this, bring it up and just make it a negative exponent. So we have g prime of t is equal to first 2t plus 5. Because I have my first and my second factor, I'm going to use the product rule with this. 2t plus 5 times the derivative of the second. So the derivative of the second, we'd bring the negative 1/2 around front. Negative 1/2 t to the negative 3/2. So negative 1/2 minus 1 is negative 3/2. So we have that. Plus first der second plus second. So plus t to the negative 1/2 times the derivative of the first, which is 2. So we end up with g prime of t is equal to, now we have negative exponents, so those negative exponents, we're going to bring those powers down to the bottom. But we have to be careful with this because we have the 2t plus 5, and that's times a negative 1/2. And then that's going to be over. I can take this. Remember that it's only this t to the negative 3/2 that goes to the denominator as t to the 3/2. Then we have plus, so a little bit of work to do here, 2 over t to the 1/2. Now I think to myself, I want to get a common denominator right off the bat. And the common denominator would be t to the 3/2. So if I'm going to make a t to the 3/2, I'm going to multiply the top by t and the bottom by t. Okay? Because think of what that means. T to the 2/2, t to the 2/2, it'd be t to the first power. All right? So I get the same denominator, t to the 3/2 power there. Okay? Let me make this a little bit smaller here. Okay, so now I'm going to distribute the negative 1/2 in the first grouping, so I get g prime of t. Let's switch back to blue. So that's going to be negative t minus 5/2. That would be over t to the 3/2. And then I get 2t. So it's plus 2t in the numerator, and that would be over t to the 3/2. Okay, so now I'm going to combine numerators and give my final answer. So I have g prime of t then is equal to, I'm going to add these two numerators here and here. So I get 2t minus t, which is just going to be t minus 5/2. I could put 2.5, but I don't know what that was about. Here, 5/2. And then that would be over t to the 3/2. Okay. Okay, now I don't really like how that looks, so I might multiply that by 2. So I might multiply the top by 2 and the bottom by 2, just say that. So if I do, then the top becomes g prime of t. This is what I prefer. G prime of t then is equal to 2t minus 5, and then that's all over 2t to the 3/2 power. This is a little bit prettier in my estimation. Okay, so that finishes our section on product and quotient rules. And so after, let me see if oh, yeah, it does, it flows in. Okay, so product and quotient rules are done. And then tomorrow when you come in, I have a little activity for you with tangent lines, and I think we got everything here, right? Tangent lines and drawing the graph of the derivative. So product rule, as you go down here, Quotient rule, simplifying first. Okay, quotient rule, simplifying first, getting the derivative. And then where we have these two examples, the one thing I highlighted was, remember that if you're going to take the derivative, you can sometimes have a choice of using between the product rule and the quotient rule. So in the last one, I chose to do the product rule by bringing it up as t to the negative 1/2. So that's it for today. This is Alanator, and I will see you when I see you. Take care, and I'll see you tomorrow morning or tomorrow afternoon. Bye-bye.